Okay, Jesse, we're going to review how to find the roots or the zeros when you cannot factor. This is similar to some of the problems we were talking about in class yesterday. So the idea is this: when you can't factor it, you're going to have to use the rational root theorem, and this is something that you did back in pre-calc and or algebra 2. The rational root theorem says the possible roots are all of, let's see, possible roots. So you would take all of the factors of your constant term, 27, so all of your factors are plus or minus 1, plus or minus 3, plus or minus 9, plus or minus 27, all divided by all of the factors of your leading coefficient. So your leading coefficient here is 1, so that would just be plus or minus 1. So all of your possible roots would be within in the scope of the numbers displayed here. Plus or minus, this is a plus or minus here, plus or minus 3, plus or minus 9, plus or minus 27. And then from there you would have to do synthetic division to figure out which, excuse me, to figure out what your roots are. Sorry, Jesse. So we have 1, negative 9, 27, and negative 27. Those are our coefficients from our polynomial. And we'll just pick one of these to start. So let's say I tried 1. Bring down the 1, and this is just a review of synthetic division. You bring the first term down, multiply these two terms together, and then that goes here. So 1 times 1 is 1, and then you're just doing addition. You get negative 8, and then you do the same thing again. 1 times negative 8 is negative 8. When I add those together, I get 19. 1 times 19 is 19, and I end up with negative 8. This last number here is your remainder. If you end up with a remainder, then this is not a root because it's not a factor as long as you have a remainder. So I'm going to try something else. Maybe I try 3, and I'll go with 1, negative 9, 27, and negative 27. Bring down the 1 and start the process. So 3 times 1 is 3. Add those together. You get negative 6. 3 times negative 6 is negative 18. Add those together. You get 9. 3 times 9 is 27. Add those together and you get 0. So then you know that 3 is a factor. Excuse me. So you know then what you have left over here are the coefficients of your depressed polynomial, basically because we started with x to the third and we did some division. Our new polynomial is now x squared, and these are the coefficients. So you would then have x squared minus 6x plus 9 equals 0. Because 3 was a 0, you know that x minus 3 is a factor. So this is a factored form of that original polynomial. And then from there, you know that you can go ahead and factor this. If you couldn't factor it, then you'd have to either do the quadratic formula or completing the square or something like that. If you start off with a higher degree, so maybe you start off with a 4th degree polynomial and you get down, you find one of the factors, and then you still have a 3rd degree that you can't factor, then you would just start the whole process all over again. Okay, so here I end up with x minus 3 and x minus 3 equals 0. And so this is really x minus 3 to the 3rd is the same as what you have up here. So that is the idea behind finding the finding the zeros when you can't factor it. You just use the rational root theorem. Let me also show you this, Jesse, really quick. This is a 4th degree polynomial. You see here that we took all of the factors of the constant term divided by all of the factors of the leading coefficient, and then listed out all of the possible roots. We tried some. We end up with 2 here as a root, which makes x minus 2 a factor, and now I have this 3rd degree polynomial, which I also cannot factor, and so I went through the process again. These are all of my factors I tried. Negative 3/4, and that worked, and that brought me down to this quadratic equation, which also cannot be factored, so I had to use the quadratic formula to solve it, and then these are the 4 roots of that polynomial function. So that's just a quick look as to how to do that. Hopefully that'll help you out. If you have any questions, let me know. Have a great weekend, Jessie. I'll see you next week. Take care. Bye-bye.